Hey everybody, welcome back to the conclusion to this problem that we were doing as we were trying to divide rational expressions. So the first thing we did is we factored, and it's looking pretty good, although I'm still a little nervous about what that is. I don't know what that is. So does he factor or not? I'm not sure, but we'll find out in a second, something really cool that's going to come up. Okay, after we factor, remember what we should do next? Let's do domains. So let's look at all the denominators. And Okay, let's see what x cannot be equal to. So domain I'll put up here. X cannot equal to. Okay, so just moving left to right, that would be negative 2 and positive 2. So I'm just going to put plus or minus 2. That's kind of cool. And then another x plus 2, so I don't have to use it twice. Now what the heck over here? That's going to be really, really unusual. Like, how do we solve that? Well, I'm going to tell you, friends, a little shortcut. When you factor a difference of cubes, that second parenthesis, remember, he doesn't factor. Otherwise, we would learn that part of the formula. The second part never factors. And not only that, but he doesn't have any real solutions. Means if you try to set him equal to 0 and solve for x, you're not going to get anything that's a real number. And we'll talk about what kind of numbers you will get later. But for now, I'm just telling you, you don't have to factor, and you don't have to set that equal to 0, because you're not going to get any answers that are helpful. Okay, so when you factor a sum or difference of cubes, you don't have to solve for that longer parentheses. It's okay. Okay, so there's my domain, but now I'm not going to box the domain for a second. You're going to see why in a sec. Okay, so now let's do like we said. Dividing by a fraction is the same thing as by the All right, so here's go. So we're going to keep the first fraction the same, right? Okay, this is all the same. Great. Dividing by a fraction is the same thing as multiplying by the reciprocal. So now I'm going to write the reciprocal now of the second frac, but I'm going to go ahead and flip it in its factored form. So it's a little bit tricky, but we factored it first, so we saved a lot of time by doing that. All over the strange thing that did not factor. Now, something really, really important came up. So I'm going to put a big star on this step. Before I cancel, do you notice that because the numerator that I had up here suddenly becomes the new denominator? Friends, we've got another domain problem here. So that numerator became my new denominator. We don't want that equal to 0 either. So we have to consider that for domain. That's why I didn't box it up here, because I have to be careful in case there's another x value that would be bad. Now, okay, good news is this part down here, this numerator, as a numerator that became a denominator, is again from the factoring of cubes. How do I know that? Because I see it over here. So I know right now that we can't solve him. But you do need to take that step. After you flip your second fraction, reevaluate your domain now, because you have a new denominator right here. Okay, so maybe this is what we need to think about, friends. Ready? When you think about domain, you need to consider, ready? You need to consider the x values from here, the x values from here, because those are both denominators right now, and because you're dividing, this will eventually go on the bottom, so you need to think about the denominators for that. But wait, you're thinking, well, this denominator right now, Mr. B, that's going to become the numerator. That's not going to be a problem when he's up there. And you're totally right. But right now, at the beginning of the problem, he is a denominator. So we do have to be careful with his domain. So when you think about domain on these kind of problems, when you're dividing, you need to think about one denominator, two denominators, and another soon-to-be denominators. So look at all three parts for your domain. Okay? So now my domain is done. I looked at all three parts. That is my final domain. Sweet. Now, let's play. This is where we get to cancel. So first of all, notice that here on the bottom right, this whole thing is not factorable. So I'm going to put him in his own little factor notation so we can see him. Okay, remember, we can either cancel up and down or diagonally. So for example, over here on the left fraction, do you see that I have x minus 2 and x minus 2? I can kill that up and down. Poof, poof. How about the x plus 2's? That's diagonal, but eventually they would be on top of each other. And look at this. This is my favorite part. Look at this huge factor. Yeah. Get. Oh. Nice. Oh my gosh, that was so pretty. Is there anything left? Well, let's see. On top I have x squared minus 2x plus 4. And the bottom, nothing. You can say it's over 1 or just leave it like that. Oh my gosh, that was so pretty. Look at how terrible it looked up here, and look what it turned into on the bottom. Wow, that is hot. That is hot. So that's how you multiply and divide rational expressions, folks. Factor everything first, then work on your domain from the denominators, and then have fun. Destroy all the common factors that you see, top and bottom. Next time when I see you, this one gets a little bit tougher. Now we're going to try to add and subtract fractions, which, if we're just dealing with numbers is not bad, but when you're, that's crazy. Oh my gosh, did you just look down at the bottom? Oh, just got a little sick to my stomach. But we're going to deal with that next time, nice and slowly. Great job on the beginning of section P.5, folks. I'll see you next time.